Hi, good morning. This is the e-learning lesson video on limits. We're going to finish up the last three examples from the notes from Wednesday. So again, for number 4, it says we want to graph the function, then use the graph to find the limit, if it exists. Okay, so the function that we want to try to find the limit for is cosine x, and we want to find the limit of this function as x approaches pi. Okay, so here we have the graph of the cosine function, and again we want to find the limit as x approaches pi. So again, when we are looking at the graph, right, so here's pi, here's the input value of pi. So we want to approach this input from the left and from the right. So coming in from the left of this graph, the limit of the function coming in from the left of pi, so it's going towards this point, which is -1. Coming in from the right of pi, this graph is also approaching -1. So the limit as x approaches pi for cosine x is -1. Example number 5, we are given a piecewise function, and we want to find the limit as x approaches 2 of this particular function. So again, the first thing we want to do is to graph this function. So it's a piecewise, so there's going to be, again, two parts to this graph. One part is going to be x squared, which we know is a quadratic, which means the graph is going to be a parabola. And the other piece is 2x minus 1, which again we recognize as a linear function. Okay, so the parabola part, the quadratic part of this function exists when x values are less than or equal to 2. The linear part of this piecewise function exists when x is greater than 2. Okay, so I'll give you a moment here to go ahead and graph those two on a graph grid, and then we're going to try to find the limit of this function based off of the graph. Alright, so this is what your graph for your piecewise should look like. Again, for domain values of x less than or equal to 2. Alright, the quadratic part of our function exists. So here you see our parabola. So here's our x value of 2. So again, we are looking for, again, that part of the graph that is less than that. So you notice that I only drew part of the parabola. Right? On the left side here, I do have the arrow because again we are open to going to x values which are smaller than this point. Right? But I do not have an arrow drawing up from this side of the parabola because again this part of the piece of the function only exists up till and including the value of 2. Right? When I plug 2 in for x, I get 4, so here's my output value of 4. Right, so for the linear part of this piecewise function, the domain starts at a value of 2. So when I plug 2 in for x, I get an output value of 3. So now again, you notice here at 2, I got this open circle at 2, 3, because again, I don't have the or equal to. Alright, so I have that open circle. And then every value after that, when I plug in other values in for x, I continue on with my linear function. Okay, so here's the graph of the piecewise. So that's the first thing you need to be able to do for the homework, for the part of the homework where it asks you to graph the piecewise, is you want to graph all pieces on your graph grid. Alright, so now that we've done that, we want to go ahead and find the limit of this function. So for this particular limit, we are trying to approach an x value of 2. Okay, so we've got to pay attention to when we're finding these limits, again, what domain value we are interested in. Okay, so again, this can change from problem to problem, so we want to make sure we're paying attention to this. So we want to approach that x value of 2. Alright, so coming in from the left of 2, alright, this part of the piecewise goes to this point. Coming in from the right of 2, so we're coming from this direction, so that means we're coming down over here. Right, as we come in from the right of 2, we are approaching this output. Now, as we noted before, right, for the quadratic part, as we get to 2, our output is 4. As we approach from the right side here to 2, we are approaching an output value of 3. So because those don't match, our limit for this function does not exist. Okay, so we do not have a limit that exists for this function as x approaches 2 specifically. Not to say there is no limit you can be found for this function, it's just there is no limit for this particular domain value of x approaching 2. Alright? Alright, for the last part of the homework for today, you're going to be using your calculator. It says use your graphing calculator to find the limit, round to 2 decimal places. Okay, so this was kind of a little bit of an issue when I was grading your homework from last week. Right? I want you to include the table in your work. Okay, so again, it's all coming from your calculator. So you want to find the limit of this function as x approaches 3. So then you're going to go to your calculator and you're going to enter in that function in your y equals. Okay. So I'm going to give you some time to go and do that. You can pause the video to do that and enter that in your calculator. Alright, so because we want to round our answer to 2 decimal places, and we want our limit for this function as x approaches 3, then we're going to press second table set to get to this part of the calculator, get to this screen. Alright, we're going to start with our value of 2.97. Again, we're starting with 2.97 because we want to approach 3 on both sides, so this is going to be the start of our table. And because we want to go to 2 decimal places, we're going to go ahead and put our change of our table to 0.01, 2 decimal places. Alright, so once you've set that up, you're going to go ahead and press second table to get to the table. Alright, so again, this is the one that we want to go ahead and copy down onto our homework. So 2.97.471 approximately. And input value 2.98, 0.469. When we enter in 2.99, I get 4.67. Enter in 3, that's where we get our error. 3.01, 0.462, 3.02, 0.460. Alright, so here's the table that you want to include in your homework. So again, we want to find the limit of this function as x approaches 3. So here's 3. So as we're coming in from the left, so we're going to start with the smaller values and moving towards 3. Alright, you see that our output values are shrinking as we're coming in from the right. So from the bigger values than 3 coming in from the right, then our y values are growing. So looking at this middle section, so, okay, where, right, is this all going to go to? Right, so it looks like we are headed towards about, right, in estimation of 0.46. Right, you have 0.469, 0.467, so it's definitely shrinking towards that value. Here we got 0.460, 0.462, so then that seems to be growing to about that value. Okay, so the limit of this function as x approaches 3 is about 0.46. Alright, so again, when you're doing this part of the homework, make sure you use your calculator. Make sure you copy in that partial part of the table. Alright, that's going to help you find the estimated limit for that function. Alright, okay, so you guys have a great day, and I'll see you later in the week.